Hey y'all, this is Mr. Nguyen, and I wanted to make a quick little video to help y'all out. I know some of the videos on the playlist may not be as exciting, so hopefully the video with me in it will give you a little bit more incentive because I want to try to help you guys out and do this in an efficient manner. So I wanted to do a video so I can just send it to you guys. So I'm gonna be going over the playlist, finding unknowns on finding unknowns in right triangles. And before we begin, I kind of wanted to go over a little bit of the history of right triangles or trigonometry because I find it interesting, and I think a little knowledge of the background can give you a little better appreciation of how far and how long it's existed. So the study of trigonometry, right? Trigonometry, first and foremost, directly translates to measuring triangles. Specifically, when we do trigonometry, and specifically in this playlist, we're going to be looking at right triangles. These studies go as far back as 500 BC. Think about that. That is before. That is before a lot of things were invented, right? And when I say we, I mean people, civilization were able to find fixed relationships in triangles, right? And these applications go to as far as physics today to engineering. It's amazing if you ask me. So just let that simmer. Just think about it. I think it's kind of cool. But anyway, let's move on. Right. So the first thing we want to go over in finding unknowns is the mnemonic device SOHCAHTOA. Okay. I'm sure y'all heard it before, but let's go over it one more time just to make sure that we get it drilled in our head. Okay. SOHCAHTOA, spelled S-O-H, okay, standing for sine, C-A-H for cosine, and T-O-A for tangent, tells you in the relationship to the angle what measurements are going to give you the sine, cosine, and tangent of the right triangle. So we're gonna jump right into it with sine, right? And sine relative to the angle in which you are looking at. Opposite and hypotenuse, which is going to be fixed no matter what. Hypotenuse will always be where the hypotenuse is going to give you the measurements of sine of the degree of the angle. Okay, so if I were to point that on the triangle over here, if we were to look at this angle right here, right, and let's just make up a measurement. Let's say 30 degrees, okay, and I gave this a 2 and I gave this a 6, right? I just made those numbers up. So if I were to plug in opposite over hypotenuse, right, and I were to write it as the function of sine of 30 degrees is equal to 2 over 6, and I were to plug that into a calculator, it would give me 1/3, right? It would give me 0.33 repeating. And because the right triangles have fixed relationships with each other. Why this is important and why we can use this to find missing sides is that instead of just finding two sides, which numbers we already know of, right? If we don't know what the adjacent is here, we can use cosine, or we can use tangent in order to find what this x is going to be. Okay. So we erase this, okay, and run through a quick example, right? For demonstration's sake, let's use cosine, okay? If I were to plug in cosine, right, of 30 degrees, right, we always put the degrees right after the cosine, 30 is equal to adjacent, right? We don't know the adjacent, so we're just going to place an x there. Right? X over hypotenuse, and we know the hypotenuse, right? And if you can recall, okay, so now we have a function, right? And we have one unknown, okay? If you remember algebra, you can always solve for the unknown using algebra, okay? So all we're going to do is set this up so that we can plug it into calculator easily. We're going to have to get rid of this 6, right? And so in order to do that, we multiply both sides by 6 over 1, aka 6. So remember, what you have to do to one side, you have to do to the other side. And so now you get 6 times cosine of 30 is equal to x over 1, right? And denominator is 1, so we can just say x. Okay. Now, if we take our calculator, okay, tiny little calculator here. I'll zoom in so you guys can see it. I'm going to type in cosine 30, okay, cosine 30, enter, okay, I get an irrational number, and I'm going to times it by 6. Okay, and we're going to round to the nearest tenth just to make life a little easier. So what we get is 5.2, okay? X is equal to 5.2. And now we know using cosine, okay, we could have done tangent and got the exact same number. But we know that this x, this missing side right here, is equal to 5.2. Cool, right? You can do this with any side as long as you have enough information. Let's go over one more, okay? Let's go over one more where the unknown is going to be on the denominator, because I know sometimes that throws people off trying to isolate the denominator when it's the unknown. Okay, so let me erase this real quick. All right, so we're gonna try to find an unknown on a right triangle when the unknown is on the denominator. It gets a little tricky, but it's the same concept. You just plug in and do algebra. Okay, so I'm gonna throw some different numbers up there just to shake it up a bit. Okay? So right here, the angle, I'm gonna give this 22 degrees, okay? And I'm gonna give the measurement, the opposite over here, 14 meters. The measuring unit doesn't matter, it's the math that counts, right? And so I'm gonna ask myself, right, what is the measure of the hypotenuse, right? Okay, since we don't have two of the sides, right, we can't use Pythagorean theorem, right, because we're missing this one. But we can use we can only use right here sine, right here, in order to find what x is. I mean, you could find the adjacent using tangent and then figure out the x using Pythagorean theorem, but whatever, however you want to do it, as long as it makes sense to you and you do the math right. Okay, so we're gonna use sine here, right? Sine, okay, and what is the angle? The angle is gonna be 22, okay, in parentheses, is equal to opposite, right? And we have 14 for opposite, over hypotenuse. And remember, hypotenuse is the unknown, so we put x here, okay? This one, I like to work the algebra just by moving the x to the other side, okay? So what I like to do is I just multiply both sides by x, okay? And so you get x times sine 22 is equal to, right, 14 times x over x, right? And you have x over x, right? And so if you have the same variable over each other, right, they're just going to cancel out, right? So now you have, now this just turns into x times sine 22 is equal to 14, right? To get sine over to one side, right, and this in itself is a term, we want to just divide by sine 22, okay? And divide both of them by sine 22, okay? And now you get x is equal to 14 divided by sine 22, okay? The hard part's done. All we need to do now is just plug it into a calculator. Okay, so what I'm gonna do, right, I'm gonna do some rounding because it's a little tough on one of these basic calculators. I'm gonna do sine 22, okay, I get about 3.37, okay, you see that? I'm gonna use 37 right there. So I'm gonna do 14, okay, 14 divided by 0.37, okay, And the number I get is 37.8. Okay, if we round up. Okay. So now we get x is equal to 37.8 meters, right? We now know what the hypotenuse is, simply because we use these functions of SOHCAHTOA. Awesome, okay. Cool. Hopefully this helps you find the missing sides. What I'm going to go into next is finding the angles, because I know that's a big part of the playlist as well. And it's just as easy. You just do a different step on the way to getting the answer. Okay, we're back. Okay. So far we've covered finding unknowns of sides using SOHCAHTOA, right? We've always been given the angle, and putting an unknown in the ratios was easy enough, right? We just plug it in and do simple algebra and then solve for x. The next thing we want to do, and which is going to be a large part of the playlist and a good foundation for those going into higher math, is trying to figure out this angle right here, right? It's a little daunting, but it's just as easy. There's just one different step on the way to find it. Okay? So right off the bat, okay, we're gonna see what information we do have. Okay, so this triangle right here, okay, it's a right triangle. We have relative to this angle, right, the unknown in which we're trying to figure out. I'm going to denote this as x. Okay. Adjacent, we have relative to this angle, adjacent, it's going to be 16. It's touching this angle. And we have opposite. It's going to be on the opposite side of this angle. Okay. So we don't have the hypotenuse, right? So we can't use sine or cosine, because then we'll have two unknowns. The only thing that we can use is tangent. So we just plug stuff in, right? Tangent, okay, and this is where it's a little different. For the parentheses after tangent, we're going to put x because we don't know what it is, okay? All right, and we're going to do opposite, which is going to be 9 over adjacent, which is going to be 16, okay? What we have to do to find what x is, right, is we have to find the opposite of this, right? And the opposite, in math, we just call it the inverse. More like undoing. Opposite is a little, it's not exactly true in all situations, but to undo tangent, right here, all we have to do is find the inverse of this, right? So x is just going to be tangent inverse. And when we denote tangent, we do -1, okay? 9 over 16. Okay. It's actually that easy. Okay. So we're gonna take our calculator. We're gonna take our calculator right here. Okay. And most scientific calculators should have this, right? On this one, in which I think we will be using more often than not, we're gonna place second. We're gonna press second right here. Tan, and then if you see on the superscript above tan, you see tan -1. So you're going to click on that, and then it's going to give you a parentheses, and you're going to input that fraction right there. So we're going to do 9 divided by 16. Okay, you can close brackets if you want. You don't have to close brackets. I like to do it though. You press enter, and so you get 29.36. Okay, 29.36. So x is equal to 29.36 degrees. Now we know that this x, this angle which we didn't know at first, okay, let me put it outside it so I have more room. 29.36 degrees is what that angle is. That's all it is. Plug it in, find the inverse, and you get x. And you will probably, most likely than not. Okay, so the last thing I want to go over, and it's the last few questions on the playlist, is the word problems, right? Just extracting the information from word problems, and this is a skill that you'll need in other playlists as well. So hopefully with this example, it'll give you an idea of how to take the information you're given in words, right, in a story, and drawing it into or interpreting it and writing it in a way that you can understand. Okay, So I've written a problem already on the board, and I'm going to read it to you because just in case you can't see it from there. But it says, a pole stands 8 feet off the ground. Okay? Jimmy climbs up the pole to tie a rope on the top. Okay? He stretches the rope as far as he can from the pole to the ground. He knows the rope is 24 feet long. What is the angle of the elevation from where Jimmy nailed the rope to the ground? Okay, that was a lot, but let's read it over, and this is all assuming that the angle from where the pole is to the ground is a right angle. Okay. Now we're going to read it again, but as we read it, we're going to slow down and write down the pieces of information. Okay. So we'll start off with a pole stands 8 feet from the ground. Okay. There's a pole. Okay. Just one pole. 8 feet. Okay. That's all we know so far. Jimmy climbs up the pole and ties a rope. Okay. So there's a little rope. Right. He ties it. Right. We don't know where he's pulling it yet. And he stretches the rope as far as he can from the top of the pole to the ground. Okay. Right there. Okay. We know that from the pole to the ground, the angle is 90 degrees. Okay. It's a right triangle. Okay. In case you didn't know. Okay. He knows that the rope is 24 feet long. Okay. So right off the bat, we know that we have 8 feet is the pole, and then the string right here is 24, and we know that it's going to be a right triangle. So we can tell right now that 24 is equal to the hypotenuse. Okay. And it's asking, what's the angle of the elevation from where Jimmy nailed the rope to the ground? Okay, so this is where he nailed it to the ground, right? And this is the ground. So we want to find this angle right here. Okay. Okay. Cool. Do you see what we just did right here? Right. We took the information there and we drew it out as we read it. Okay. When in doubt in math, draw it out. Say it with me. When in doubt, draw it out. That works across math. That's not just trigonometry. Okay. So cool. Now we have an unknown of that angle, right? And to solve for it, I'm gonna go kind of fast on this one because it was covered in the last video. Is that we want to figure out what function of SOHCAHTOA can give us the angle if we have opposite and the hypotenuse. And if you look at my device right here, opposite and hypotenuse, we can use sine. So we're going to do sine x, right? Angle is the unknown here, is equal to opposite, which is 8 over 24. Okay. We can simplify that, and that's just equal to 1/3, right? Because 8 divided by 8 is 1, and then 24 divided by 8 is 3. Okay. Now we just find the inverse in order to find the angle, right? Remember when we try to find the angle, we find the inverse, how to undo the function, right? So x, right, the angle, is equal to sine inverse, and we denote it with the -1 superscript, parentheses 1/3. Okay. We're going to plug that into our calculator. Okay. Handy dandy calculator. Second right here. Hit sine right there. Okay. Then we're going to do 1 divided by 3. Close parentheses. Equal. Give it some time. And it gives us, if we round up, it's going to be 19.5. Okay. X is equal to 19.5. And since that's the angle that we're looking, this is degrees. That's it. That's all it is, okay? When in doubt, draw it out.